Welcome back to the 36th part of Debugging at Scale, where we don't need no server. Although, not really. We do. It's just managed, you know. Like many things in software, the benefits of serverless or platform as a service are great. We can ignore infrastructure complexities and focus on code. Scaling becomes seamless and, when compared to some alternatives, affordable. Performance is also great under the right conditions. Here's where engineers expect the other shoe. What's the downside? The downsides are many. Costs are hard to control and can unexpectedly run amok. Performance is sometimes hard to navigate in a decoupled architecture. But to me, the worst offender is the process of debugging. It facilitates a culture of debugging in production using logs. Serverless deployments are so complex and nuanced, they grow to a point where local debugging becomes untenable. Best practices such as dev or staging environment become completely disconnected from production. This module doesn't provide a magic bullet. This inherent problem of debugging in serverless isn't easy to solve. I recommend developers use serverless as we use duct tape. Serverless is great at solving things, but not at serving as an architecture on which to build your software. At least, not at the moment. Serverless isn't a single standard. Far from it. There are many competing vendor-specific tools and various levels of abstraction. Every tool has a very different process, and despite multiple attempts, we don't have successful standardization. The upside is that most frameworks are similar. In this module, I will focus on AWS Lambda, which is popular and supports multiple languages, including Java. Most of the concepts that apply here would apply to other serverless frameworks as well. Serverless debugging could be viewed as an oxymoron. It's managed, deeply controlled, and disconnected environment. We don't have most of the typical debugging tools at our disposal. The distributed and controlled nature of the environment essentially blocks any chance of remote debugging. The external tools we discussed in the third module are out of the question. The problem of concurrency and scale can be very extreme in the world of serverless. To make matters worse, subtle changes in the underlying platform can cause sudden failures. Serverless deployments tend to be fail-safe for the most part. This approach can create cascading failures that balloon into serious cost issues. This can be financially hazardous. In this chapter, we'll discuss the following debugging strategies when dealing with a serverless problem. Debugging locally using the IDE remote debugging capabilities. Feature flags aren't a classic debugging tool, but they let us tune behavior in a way that helps us isolate the problematic area. Staged rollouts and canaries help us find a bug before it impacts everyone. You might have noticed I skipped a couple of things. Logging is one of the most common tools when debugging serverless deployments, for instance, with tools such as CloudWatch. Since we covered logging in the fourth module, I omitted it from the list. The same is true for tracing and observability, both of which I will cover in the next module. I would argue they are the most interesting ways to debug serverless. Because of these complexities, testing is a remarkably important feature of debugging serverless code. I suggest referring to Module 4 about unit testing and working on test coverage for serverless, this is often the best option. I won't cover testing again here. Logging is pretty much the only option advocated by most serverless users. Logging has many benefits and many faults. To me, the biggest fault is storage and CPU. With serverless deployments, we pay for CPU time, logging slows down execution, and brings up the price we ultimately pay. The problem of overlogging that I discussed before is compounded when running in a serverless environment. Still, there's not much else we can do. One of the ways serverless providers have evolved over traditional platform as a service is through the adoption of functional programming concepts. An important one is idempotency, which is a concept rooted in mathematics, meaning a function will have the same result if we pass in the same values. This seems obvious. If we have a function called add to which we pass the values 2 and 3, the result should always be 5. At first, when you hear about this concept, it seems that this is the way our code works, but it isn't always the case. If your function relies on an external web service, the result might change. At that point, it will no longer be idempotent. A good example would be if the add function would handle currencies and then would return a different currency, for instance, euro, and return USD. In that case, the result would fluctuate with currency conversion changes, but there's a simple solution. Accept a timestamp. By requiring a timestamp for the currency value, we can force consistency in the result. This is functional programming 101, but it's also good programming practice in general. It makes debugging and testing serverless functions easier. We can rely on consistent, verifiable results. A log will include the input that includes the input should in theory match the output. Then, once we have the logs, we should be able to reproduce the problem. A common best practice in development is using a separate environment. This is useful for testing. We would usually have a dev environment into which nightly builds are uploaded and staging, which is a step before production. These environments let us test that our application is working correctly in a pseudo-production environment without the risk. These environments are one of the chief advantages of using Kubernetes. Setting up mirror of production environment becomes trivial, especially when using infrastructure as code, such as Terraform. With serverless deployments, this isn't as trivial, and because of the nuance involved, it's very hard to get these environments in sync. The main challenge is maintaining consistent environments. A typical deployment is complex. It can include multiple dependencies and endpoints. Aya can help with this process as well. Unfortunately, this raises the complexity level, which reduces some of the benefits in adopting a serverless architecture. Serverless offers interesting trade-offs for the casual developer. Debugging is one of the causalities as part of this process. One of the casualties as part of this process. In the next video, we will discuss local debugging in a serverless environment. If you have any questions, please use the Slack channel to ask them. Thank you.